This is Kenyon Conti, and this is my Lab 9 thin lenses. So this was a very interesting lab where we had to use a magnifying glass to determine an experimental focal length. In the first part of the lab, we measured different types of rays and how different rays will go through a surface. I can show it here. When we have a diverging lens, then the image is virtual, upright, and smaller. And then when there is a converging lens, the image is real on the opposite side of the lens, which I thought was very interesting. And we filled out this table, and we see that when the image distance is equal to the focal distance, then R goes to infinity, and it's a very, very cool mathematically how it works. Now for part 2, I used a very similar setup to this. I used my phone as a light source, and I used a magnifying glass, which I borrowed from the library. And then I taped a piece of white paper on a wall. And what we basically did, I was unable to get a picture, unfortunately, but what we were able to do is setting the image distance to 20 centimeters. Setting the image distance to different lengths and the image to 20 centimeters, we were able to find 1 over P, 1 over Q, P and Q, and came out with a kind of nice looking parabolic graph for Q versus P. However, the graph of 1 over Q versus 1 over P was much better in terms of determining what we're really looking at here. And I was able to determine my focal length of the magnifying glass, which I borrowed, was around 14.97 centimeters, with a very linear trend line right here. So yeah, this was a really fun lab, and especially this part helped me learn a lot.